All right, statistics less than 7.2, the applications of the normal distribution today. While we're on this, you definitely need to go ahead and get out your purple sheet with the formulas. Go ahead and get out a calculator. If you don't have those items, please go ahead and pause the video, get those items out, and then go ahead and start the video back up. So again, you need a purple sheet, you need a calculator. Some of you, if you bought the book, it won't be purple, it'll be actually your the formula card that comes from the company. All right, so the normal curve, z-scores. That's what we're going to be working with today. So we need to remind you how to calculate the z-score. So on your formula sheet, under Chapter 7, if you please flip to the back side of your formula sheet where Chapter 7 occurs, you will see how to find a score also. So we'll also need that formula as well. The z-score was calculated by taking the value minus the mean divided by the standard deviation, and we're going to need that today. So find the area of each shaded region. So we're saying we're supposed to find this area here, and we know that this z-score corresponding to this bar is at 4/10. So when you want to find the area, there are tables that you can use. I prefer to use the calculator, but you got to understand what the buttons are telling us. The normal CDF would be from the left bound to the right bound will give us the area. So when I want to find the area, we use normal CDF, left bound, comma, the right bound. The left z here actually keeps going left forever. So I like to go ahead and just use -100. Now the button normal CDF is going to be under, you're going to push on your calculator. I don't know if we're going to see the buttons, but we're going to try it here. All right, so we're going to push the word second. You're going to push distribution, which is the vars right here. So second distribution. Now I'm looking for the normal CDF, which happens to be number 2 on my calculator. So I'm going to choose number 2. Now it says lower. So the lower is referring to the left. So my left number is going to be -100. Okay. The upper number, that means it stopped at 4/10. So that's 0.4. That's 4/10. We're going to leave our mean and standard deviation at 0 and 1. And you're going to go to paste. And then after that, you just push enter. And that's going to give you the area. So again, when you want the area, the normal CDF is going to give you the area. It gives you the area between the two z-scores. See, that's what it's telling you. So this time I wanted the area, but I want the area from a z-score of 1 2/10 and higher. So we would do a normal CDF from 1 2/10, say to 100. Once you type it in, then this should be your answer. On the next example, we want the area between a z-score of -2 3/10 and 75/100. And it's actually just as simple as that. You want a normal CDF. Remember, when you want the area, find the area, means you are going to do the normal CDF to find the area. All right, from the left bound to the right bound. So even when you tell it in the calculator that I want to do a normal CDF, it's even asking you for the lower bound and the upper bound. All right, I want to find the area here. So I could do a normal CDF from -100 to -1 3/10, get that answer, and then add it to a normal CDF from 1.9 to 100. But see, if we remember back, we've talked about that the area under a normal curve is equal to 1. So if the entire area equals 1, well, what if I found just the area of the white part? If I found the area between the bars, could I subtract that from 1 to get the area of these two shaded regions? And so that's what I would do personally. So I would do 1 minus the normal CDF from -1 3/10 to 1.9. This time we are to find the z-score corresponding to the given area. So I am given that this area to the left is already 6/10. See, I already know the area. I need the z-score. That should be like an inverse. See, when y'all ran a normal CDF, it gave you the area. Now, if I know the area and want to go back to a z-score, that's going to be called an inverse norm. So again, we will be using the inverse norm, but it will only do the area to the left. It will not do area to the right. So we would just say the inverse norm of 6/10, and that would give me my z-score. See, this time I know the area to the right is 70%, basically, of the whole thing. or it's 7/10, sorry. But my inverse norm will only do the area to the left to give me this z-score right here that falls. So I would have to get the area to the left first, and then do an inverse norm of 3%. Inverse norm, I'm sorry, is under second distribution, and you'll see it under the normal CDF. And just pause the film if you need to go ahead and try and find those buttons. All right, top 15%. That means this area over here, I want the top 15%. Again, if I did inverse norm of 15%, it's actually going to give me a negative value because it's only going to give me the area from the area to the left. But I wanted this to be the top 15%. So if that's the top 15%, then all of this over here would be 85%. So I would have to do the inverse norm of 85%, and that's how I would get my z-score. If we're talking about the middle 30%, so the middle, between these two, so I should get 2 answers for my z-scores this time. If the middle 30%, that means on the outside ends together has to add up to 70%. And if I split the 70% in half between these two tails, 70 divided by 2, each of those areas would be 35%. And again, remember, to get a z-score, I have to do the inverse norm of the left area. So it would be the inverse norm of 35% to get that z. Now, because it is symmetric about this mean, 0, therefore, whatever this is for my z-score, it's negative. This would be the same, but it'll be positive. Again, because remember, it is symmetric about the mean, symmetric about the middle. And so if I was saying that middle 30%, that does mean that this z-score and this z-score are going to be equal because that is the middle 30%. All right, find the z-score that corresponds to each. Alrighty, z sub 800ths versus p sub 60. Z sub 800ths means that there is 800ths above you. P sub 60 means there is 60% below you. Make flashcards, make some notes, because if you'll understand what those mean, then it'll help you to find the z-scores. So z sub 800ths, again, meant 8% was above the z-score. If 8% is above the z-score, then that means I've got 92% below it. Because remember, to get the z, I need the left area. So therefore, I'd have to do an inverse norm of 92/100ths. Now, go ahead and try this in a minute. I want you guys to type in your calculator's inverse norm of 800ths. I'm going to pause the video, get your inverse norm of 800ths. All right, now that you've pushed play, hopefully you notice it gave you negative of this exact same answer. And the reason it does that is because, remember, they're symmetric about the mean. So if I did the inverse norm of 8%, that would have been over here for my z-scores, what the calculator just gave me. But again, it's symmetric about the middle, about that mean. So therefore, this negative z-score here would be equal to the positive z-score over here, where both of those represented an 8% on the tails. Now, percentile, the P60, that already means 60% was below. So therefore, just inverse norm, that's already your left area. So inverse norm of 0.60. So with some scenarios. IQ scores can be modeled by a normal distribution with a mean of 100 and standard deviation of 15. So we have 100 in the middle. Add 15, add 15, add 15, and then subtract it, subtract it, subtract it. All right. An individual whose IQ score is 120 is 1.33 standard deviations above the mean. That's calculated by taking its z-score. So here's the value minus the mean divided by the standard deviation. And there's our z-score. So that would be about 1.33 standard deviations above the mean. Remember, each of the marks represents a standard deviation. So what does that mean? To be 1.33 standard deviations above the mean. So if I calculated this area over here to the left, I would calculate that area to the left by doing the normal CDF from negative 100 to 1 and 3300ths. So again, normal CDF from negative 100 to there. When I do that, I would get 0.9082, which tells me then about 90.82% of the population has an IQ score below this individual whose score was a 120. About 90% of the population has an IQ score below a 120. It also tells me that about 9.18% of the population has an IQ score above 120. So the pediatrician finds the height of over 200 3-year-old female patients. The heights are approximately normally distributed with a mean of 38.75 inches and a standard deviation of 3 1700ths of an inch. Find the proportion of 3-year-old females that have a height of less than 35 inches. So if I'm able to, first off, remember that was the mean is the middle. Okay, standard deviation of 3 7/10. So let me go ahead and take the 35 and let's get that to a z-score. So 35 minus the mean, divide by the standard deviation. So I took 35 minus this mean of 38.75, divided by the standard deviation, gave me a z-score of negative 1.183. So I know it's just barely past one standard deviation below. It's right there. Now we were looking at, find the proportion of 3-year-olds have a height less than that. So therefore then I would want the area from a z-score of negative 100 to that z of negative 1.1830. And again, to get the area, that's the normal CDF. So we go to second distribution, and you choose normal CDF from a z of negative 100 to a z of negative 1.830. Z-scores are based off of a z-score in the middle of 0 with a standard deviation of 1, 2, 3. That's the z-scores. Pediatrician, same scenario, but this time I want the proportion of 3-year-olds that have a height between 35 and 40 inches. Well, between 35 and 40 inches, I need to get the z-score for each of those. So again, I take 35 minus the mean, divide it by its standard deviation. 40 minus the mean, divide by its standard deviation. So I'm really looking for the area between a z-score of negative 1.1830 and 0.3943. Okay, so I want that area between these two z-scores. So that would just be a normal CDF between those two z-scores. And again, on your test for me and your test for your final exam, please always make sure you guys write down what is the formula that you're using for your z-score. Please draw this normal curve. Show us where these values fall in relation to how many standard deviations away from the mean it is. The combined verbal and quantitative reasoning score on a GRE exam is normally distributed with a mean of 1,049 and a standard deviation of 189. It says, what is the score of a student whose percentile rank is the 85th percentile? See, 85th percentile means 85% is below me. Notice every time I draw the curves, I also write down what the mean and standard deviation is. It's easier for me, instead of having to go back and read in the story, to get the numbers. So I like to immediately write down the symbols, write down my normal curve, because I was told it was normal. 85th percentile means 85% is below. I know the area, I want the z. If I know the area and I want the z, that was the inverse norm to get that z-score. So inverse norm of 85%, because I know the left area. That gave me a z-score. Now on your formula sheet under Chapter 7, if you will go take a look, there's a formula that says finding the score. Pause the notes, go find that on your formula sheet, please. Okay, now that you're back with your formula, it says finding the score is the mean plus the z times the standard deviation. So my mean was 1049. My z-score was 1.0364 with a standard deviation of 189. See, you guys, when you found that z-score, that was telling them that you want to be 1.0364 standard deviations above the mean. That's why this is now plus that z-score times your standard deviation. And therefore, to be in the 85th percentile on the GRE, a person must score at least 1245 on it to be in the 85th percentile rank. It's known the length of a rod is normally distributed with a mean of 100, standard deviation 45 hundredths. Notice I drew a normal, drew a mean, drew my standard deviation. Suppose the manufacturer wants to accept 90% of all rods. What's the middle 90%? So the area in the middle is 0.90. That means I've got 10% to cut in half. That means 5% is this area on the left. If that left area is 5%, to get its z-score, we would do the inverse norm of 5%. So again, when you know the area on the left and you want the z-score, you do the inverse norm. Now remember, this was splitting at 5% here and 5% here, so that's why I did a plus minus on that. So I do have a negative and a positive z-score. Now remember, we're determining the lengths of the rod, so that means we are finding the lengths. On your formula card, chapter 7, you'd go find the score, I think is how it's titled. Plug in your values. Remember, we had a positive and a negative z-score there, so type it once with a minus, once with a plus, and there would be your final answer. That the middle 90% of the rods would have a length between 99 and 26 hundredths and 174 hundredths of a centimeter. So we have done find the area. That would be normal CDF, left bound to right bound. If it's shaded forever to the right, use 100 for the right. If it's shaded forever to the left, use negative 100 for the left one. Finding a z-score, that you have to have the left area and you do the inverse norm. Z sub 8%, that means the top 8%. P sub 60 means the bottom 60%. How to find a z? You do the value minus the mean over standard deviation. How to find the score? This is the formula we use. So at this time, please do at least the multiples of 3 before you come to class tomorrow. It would be greatly appreciated. Thank you.